Good morning or good afternoon, depending on where you are, depending on your time zone. This is Darius, and I'm here with my colleague Sébastien to give you a first overview, a quick overview of our latest offering, namely the ability to run our compilers on Microsoft's .NET Core. So by means of an introduction, I mean, this slide has been shown for the last couple of years in a number of settings and really describes our current offering, namely to have compilers for a number of languages, mainframe legacy languages, and emulators for JCL and CICS, together with the capability of developing new components in C#, VB.NET, or F# or any other .NET compliant language for that matter, having it all run under .NET or on Microsoft Azure and maintained from within Visual Studio. The whole idea of us actually targeting .NET Core is to have something which is more of an evolution than a revolution, in the sense that we provide the same languages, the similar compilers, and I'll explain how similar they are. Similar compilers for the languages, providing the same interoperability capability to write new components in C#, VB.NET, or F#. Still, having Visual Studio to develop, maintain, and debug these, but just you can now deploy them under .NET Core. The only part which are currently missing in this entire picture are the JCL and CICS emulator, which will be provided in a few months from now. So, one of the important things I want to emphasize here is that we are not, our compilers for .NET Core is indeed a new offering, but we did not start from scratch. We have been leveraging our existing compiler which targets mainframe's .NET framework, which means that all its interesting properties are still available today from version 1.0 for the one targeting .NET Core. More specifically, a totally accurate emulation of IBM's mainframe COBOL compilers, data types, rounding, exception handling, and so on. This is the compiler, so it is the very same compiler that is currently running in production in virtually all industries you can possibly think of. And it is the very same compiler, again, that has been downloaded over 5,000 times over the last year by means of our freely available COBOL compiler available on our website. So we are all very excited because, as far as we know, this is really the very first compiler made available targeting .NET Core, developed by a third party, developed by a non-Microsoft organization. This is probably true for languages, for compilers in general. It's definitely true for mainframe languages. This is really the first ever mainframe language compilers available targeting .NET Core. And it really opens new horizons. I mean, we have been bumping over the last few years into customers who, for tons of reasons, had an issue with running on Windows, Linux being the standards. More and more we get queries about the container story, and quite obviously the cloud is a very, very hot topic. So our ability now to target .NET Core, as will be demonstrated shortly by Sébastien, opens these horizons in a very compelling way. In a nutshell, what is there to say about our compilers? Obviously, they allow you to run your COBOL, PL1, or assembler code on .NET. And in a nutshell, .NET Core does the very same. The same language, the same extensions. If you really want to be ironic, you can say whatever bugs we have today in our compilers will still be present when you target .NET Core. It is, at core, no pun intended, the same compilers. We keep the capability of integrating C# code together with legacy code. Have your legacy code called C# code or the other way around. It works with C# or for any other .NET enabled language, including VB.NET, goes without saying. And now, as Sébastien will demonstrate, we can deploy these compiled modules on Docker containers by a simple click or almost. We will now proceed with the demonstration given by my excellent colleague Sébastien. This demonstration will start with Visual Studio. And this part should go rather fast because it's not about showing anything new. It's essentially about showing that whatever we had before when targeting the .NET framework is still available with virtually no change whatsoever when we target .NET Core. Sébastien, this is yours.
Thank you, Darius, for this introduction. Thank you all for attending. I will just show how this all works today on the .NET framework with our VS plugin. So let me take my solution. So we have a Visual Studio plugin integrating a code colorizer, integrating the build. We have a couple of project templates, item templates that can be used here. We have code completion and a lot of other stuff you are usually expecting to find in a Visual Studio plugin. So we can build, this is the Bartlebank. The Bartlebank is a sample application that we've written totally in COBOL. There is no C# line underneath there. And as with usual projects, once we compile it, we have a bunch of binaries that are produced. In this case, as you can see, it's directly targeting .NET Core. So this is it. This is for the Visual Studio plugin. I will go a bit deeper on debugger and so on in the next demo, but that is what we essentially have and deliver today to our customers. This is the compiler part. Now I will show you also how we run this, because compiling is one part, but we also need to execute it. From Raincode, we deliver one runner, which is basically an emulator of the mainframe system. And I will call it with my Bartle application here. And here we are. So this is a simple application which allows to manage accounts like would a bank do. There is nothing very special about that, except that it's fully written in COBOL and that it runs now under .NET, more likely .NET Core. Okay. So we've seen the compiler, we've seen how we can run and emulate this now. But most of our customers are asking more integration or custom integration, and they actually want to integrate that legacy code into more modern applications with custom C# apps, for example. So here we have another solution, which basically contains our simple projects. So this is this part. So we have here a second project containing a first COBOL program that will basically just show a message on the screen. And we have a second program that will take two input parameters, do a sum, and turn it back into a third parameter. So the COBOL part here is quite limited. It's not the sake of the demo. But here we have a C# project where we will actually call the COBOL part. So I will go through this. What we will do here, we basically will make an execution context. This is similar as what is done in the runner I just showed you. And this represents an address space within a mainframe context. We will do some memory allocation because we are doing unmanaged stuff in the managed environment. So allocate our two input values, allocate the output. We will also tell the runtime which types we are working with. In this case, it's a fixed decimal one. We will convert our input value, put them into the memory, then delegate the control to the runtime actually, so that it will run and collect back, convert back our final result to the output variable here, which we will return to the user. So I can run this now so that we can go through the program. And as you can see, I just enter my C# code. And now I will jump to the COBOL part. As you can see, I just moved in my .cop file. I have my breakpoint that has it. And I'm able to see my local variables. This is still empty because it has not been pushed there yet. But we can see in the local screen the exact same variables being set. And when I move up, I see effectively what happens on memory level at the mainframe. Okay. So let's move on. We have that second sample I showed you with the sum of the two parameters. So I've set my breakpoint there. It's hitting. I see my two values in number 1, number 2, and at the next stage, I will see that my calculation has been done in number 3. So now we've basically integrated our COBOL application into a new C# application. Okay, now let's go one step further. I will now show you a container, a Docker container. For those who are not familiar with Docker, it's basically a system that allows you to spawn virtual machines. It's basically a system that allows to spawn virtual machines with pre-configured software on it. In our case, we use the .NET Framework one, and I also prepared an image for this demo, which contains almost everything: the runtime, the emulators, the compilers, directly ready to use. So I've already started my container. I will attach to it. I hope this is readable at your side. Okay, so now we are actually in a Linux machine, which is running on my system. I can show you that. As you see, it's a Linux operating system. We have .NET here, the SDK then, and we have our FCL run, and so on, all on the machine. So I will take the sample of our Bartle bank now, which I will compile on the Linux system for .NET Core. This is not a required step. I could also just, and I will show that afterwards, can also just move the binaries from previously built on Windows system up to a Linux system and re-execute it without any issue. So this has now been built. I can run it. And we should have exactly the same application as I showed you earlier, with management of accounts and so on and so on. But now running within my Docker container on Linux and compiled there also. So for deployment and testing purposes, this opens a lot of possibilities. Okay, the last step I would show is the part I've actually already shown with the call to C# and going back to COBOL. So my last demo will be about the ASP.NET Core and the integration of it. When our customers talk about integrations, it's not only from console applications, but generally talking about microservices, JSON, web applications, and so on. So I will now push the demo to an ASP.NET Core application like this. We have here added to my web project the assembly that was built previously, so the batch copy. It's just adding a reference to the COBOL code, but just as a regular assembly. And I have a web page in which I have two simple input text boxes, and I will show a result back. This is the code behind it. It's very similar to what I've just shown you earlier with the C# call, and we basically do a couple of memory allocations and get back the result to show it on the page. Like I said, I also made a REST version of this, which is a web API controller, called it COBOL, And if you do an HTTP GET with the 2 parameters here, you will get back the sum from COBOL. So this runs on my local machine. If I hit F5, it will create a local Docker container and start the application locally. This will take a second. Here it starts. Give it a bit of time. Yes. So I can enter 2 numbers here and friendly ask my COBOL to do the calculation for me. Great. So we've integrated it, and I can now also do the COBOL part, the REST service part, sorry. And I receive the result here as a JSON item back. Now this is fine for all local development, but now how do we deploy this and how do we push this on Azure or on the cloud? Well, we have a couple of options here. We can publish. I can use just an app service, which is a Windows machine finally, or I can use an app service with Linux, and then we will use our Docker containers to deploy. I can deploy to full-fledged Azure virtual machines, or an IIS FTP server on-premise or remote. Could also just dump everything to a folder so that I can deploy it to another machine later on. In this demo, I have foreseen the first part, so the web deploy to a web app. And as we can see now in the output window, publish this. Oh, I'm still debugging. My bad. And this will now instantiate my app service on Azure, and it will launch my web app. Just again, give it a second for coming up. Okay, here it is. By the way, you can browse to that URL now, COBOL Web Azure website, and you will find exactly the same page, and you can ask COBOL the most weird computations you would like. Okay, here we are. So I can introduce another one, and let's go. This is now coming from Azure. So I think this concludes my demo. I don't know. I think this concludes my demo. Darius, maybe you have some things to
add. Sebastian, thank you so much. Are there questions? Could you please, for any questions you have, could you please go through the chat? So we have a question regarding the Bartle Bank. The Bartle Bank is a minimal application. It doesn't use 3270 or anything of the like. It is a direct console application which we deliver as part of the compiler distribution, so that people can have something to compile and run. But it is minimal in terms of its requirement. It uses EXTFH for storage, and it's a plain console application, definitely not a 3270 application, which would require a full-fledged CICS emulator, which would be a totally different story. Don't get me wrong, at no point would we make the claim that, the Bartle Bank is a serious piece of software to be run by a real bank. It is really a sample application we provide with our distribution. So how can we migrate JCLs to Windows? So this is a slightly off-topic question. we have a JCL emulator today that that can be used to run JCL portfolios of the mainframe on Windows. As of today, this JCL emulator runs on Windows. It is not ready to run on .NET Core yet, but it's a matter of time before we manage to get it to work because of the dependencies on locking and other system-oriented issues. Getting that thing to get to work on .NET Core as it does on plain .NET is a little bit involved, but it's a matter of a few weeks for us to get there.
Did I see that for the web app, it's fully supported by Azure App Service, no need for my own VM? Indeed, it's fully supported on App Service. Either the Linux version or the Windows version of the App Service. No need of your own VMs to run it. Other questions?
Okay, thank you so much for attending and for taking the time for this. So, as a takeaway, our understanding, what is great about this from our perspective, and obviously we bias, but we think what's great about this offering is the fact that it is not a development from scratch. It is not a young product. It is not an immature product. We have been leveraging on all the work that has been put into stabilizing and optimizing the REN compilers for .NET Framework and have them run on .NET Core. And it allows, as Sébastien has aptly demonstrated, to target a vast number of operating systems, both on-premise or on Azure. It leverages Docker, which is, and anyone in our business, in the business of moving mainframe workloads off the mainframe, know that the Docker conversation is a constant one. Do you support Docker? Do you support Azure? Do you support Linux? That is like the standard questions we get. And now we can answer positively to all of them. And to make matters even better, just as our COBOL compiler for .NET Framework is freely available, our COBOL compiler targeting .NET Core is also freely available. And we mean free, we mean really free. As long as you do not require support, it is not a limited version, it is not a time-limited version, it is the full product available to you. In the meantime, there's yet another question that has popped up. I will briefly answer it. The question is, have you ever done SQL store procedures written in COBOL? And the answer is yes. With our compiler, not .NET Core, because SQL Server today does not support .NET Core, it supports only plain .NET Framework. But with .NET Framework, you can use our COBOL compiler and take stored procedures that were written for DB2 and without changing the DB2 syntax into them, deploy them as stored procedure on SQL Server, the conversion, the direct conversion from DB2 SQL to SQL Server SQL happening at compile time. Just in case, is there another question? Well, thank you so much for taking the time. Thank you so much for attending. Would you have any further question? You know where to find us. Have a wonderful day.